Okay, lesson 38, overall average rate. This, guys, this idea on overall average rate is the one that you guys generally use anytime you're taking a trip. If I asked you that if we're going to travel to Chicago, you guys would say, oh, it's about what? 3 hours. 3 hours? 4 hours? 3.5? Okay, 3.5, 3.5 hours. If I asked you about how fast you took to get down there, you guys would say
80.
65. But you guys would say 65, 50 if we calculated it at the actual mileage and stuff. But if you said, hey, I went down there at 55 miles an hour, you're taking an average. You aren't going 55 miles an hour at a constant speed.
You don't know that.
You had to start at 0. You got yourself up to a speed. You also slowed down a speed.
Cruise control. I never took it off.
When you're going through Milwaukee area, you might have to slow down. If you can avoid it, you can avoid it. Things like that. But you're never really going precisely from the start to the finish 55 miles an hour. And so, overall average rate. Overall average rate has a formula. Now, I accidentally put this problem in here right away. I think I should have actually backed off a little bit on that. I actually should have wrote something in here first. So if we can, let's go to this page here. And we'll say, we should know that distance equals rate times time. You guys agree with that? So this would be before that problem. So leave yourself some room after that problem that we just wrote. Distance equals rate times time. You guys should also say that rate equals distance over time. And you guys would also say that time is equal distance over rate. It's just a modification of the first equation, yes? Now, we talk about this overall average rate. So, overall average rate.
Can we just use a distance triangle?
Yes. Overall average rate, guys, is just total distance, or overall distance, over overall time. So if I said from here to Chicago was, well, let's see, it's about 180, say 200 miles. Just make it easy, okay? And if it took us 4 hours to get there, so you got 200 miles altogether in the 4-hour trip, you would say you traveled at, it'd be 200 divided by 4, which would be 50 miles per hour as an average, your overall average. Now some of you guys are thinking, oh, it doesn't take that long. Well, what about I got just before Milwaukee, and I said, oh, I need to take a potty break. One of my kids needs to get out of the car and go to the bathroom. Okay? We stopped for 10 minutes there, 15 minutes. That's added into your time. Your time, guys, when you're traveling, doesn't stop. Okay? Your overall trip, if it takes you 3 days to get to Florida, is a different overall rate than if you got there in 1 day. Right? Some people can drive straight through 22 hours to get to Florida. Others take 2 days. Okay? They only drive for maybe 12 hours each day. That's fine. Okay? But it changes your overall average rate. So let's go back to this problem where it says Frank and Judy drive for 100 miles at 50 miles per hour. They then drive 180 miles at 60 miles per hour. Different speed zones. Maybe there's less traffic, more traffic on the highway. What is their overall average rate over the whole trip? This is different, guys, than their average rate over each leg of the trip. So what we need to do is you need to do total time distance, right? Total distance over total time. Uh-oh. I just heard we don't have time. We'll get there in a second. What was our overall distance?
Well, that would be 280 miles.
That'd be 100 miles plus the 180, so 280 miles. Over our time. Wait a minute, where's our time come in?
Well, it's 110 miles per hour.
So here's the thing.
Add and divide by.
You actually have to,
Then you divide it to get 1 unit.
you actually have to go to each leg and say, how much time does it take to go 100 miles at 50 miles per hour? No, because we're talking about total distance. So what we need to do then is say, how long does it take to go 100 miles at 50 miles per hour? Or go back to those equations that we had at the end that said distance over rate equals time. Right? So 100 over 50 is 2 hours. So the first leg of our trip was 2 hours. The second leg of our trip was 180 miles at what speed? At 60, which is together, that adds to 5. And so, what's 280 divided by 5? You get your average rate.
Let's see.
What do we get, guys?
5.2.
Take your calculator out, figure it out if you need to.
That would be 53.
53?
Sure.
56.
I was close.
Oh, 56 miles per hour. Now wait a minute, guys. Take a look what's happening here. The whole entire trip, if I took it all at once, we went 56 miles per hour. That is different than our first leg, where we went 50 miles per hour, and different yet than we went 60 miles per hour at our second leg. Now think of this. Where do we go more miles?
The second time.
In the second leg. Were we going faster or slower than our average right now? Faster. That's why it's closer to 60 than it is to 50. Because we went more in that section. It kind of goes back to our mixture problems. Yeah.
But couldn't you, if you're responding
Okay. We're going to try something different this time. It's the same initial startup that Frank and Judy are going for their drive again. 100 miles at 50 miles per hour. Then they drive 180 miles at 60 miles per hour. Now it's saying, how fast must they drive if they drive a third leg? The last leg is 120 miles long to have an overall average rate of 60 for the whole trip. Now let's do some thinking here. Our last one, where we had just the 2 first legs in there, the average overall rate was 56. I'm going to go another 120 miles, and that average is going to go up. So what do you think is going to happen in that last leg? Are they going to go slower or faster? It's going to go faster. I'm going to need to go a decent amount faster, right, to pull up the average 4 miles an hour.
Oh, okay.
So we need to kind of work this around and use our equation to find some things here. What's my total distance now?
Wait, are we doing rate or
Total distance.
Total, okay.
So all 3 legs put together
No, right?
is 200, 300, 400 miles. 400 miles over, do we know our time?
Negative.
Interesting. We do know partial times, right? From our last problem, we know we are already going how far?
5.
5 hours plus, I'm going to call it H for that third leg. We don't know the time in that third leg of the trip. But this whole entire equation of overall distance over overall time will equal overall average speed, which is now 60. And now I just have to solve for H. By solving for H tells me how long it took me to go 120 miles, which then I could plug back into the equation to find how fast I was going. How do I solve that?
Isolate H.
I'll plug that for you.
I have to get the H by itself, okay? Could I do this? Is that 60 over 1? That allows me to kind of set up a cross multiplication? I would do that. So this becomes 400 times 1, which is not too bad, equals, I'm going to put the 60 out front, 5 plus H. So that's 400 equals 60 times 5? 300 plus H.
Wouldn't it be 60H?
Yeah,
Oh, 60H. You're right. My bad. Because we have to distribute.
Careful.
Subtract 300. So 100 is equal to 60H divided by 60. Here's the cool thing. They both have a 10 in it, right? So I can just cancel zeros out. What's 10 divided by 6? Reduce it.
10 divided by 6. That would be
5/3
5/3.
equals hours. So the time that it takes for that third leg is 1 hour and 2/3.
2/3. Yep.
Or, because that's just a stepping stone, we know that I can take the 120 miles that it took them and divide it by 5/3. That'll equal my rate. Because the distance divided by time is equal to R. What is 120 divided by 5/3? Or, if we don't like that, that's 120 times 3/5. What's 120 divided by 5?
120 divided by 5.
100 divided by 5 is
60 is 20.
20.
Divided by 100, or 100
And
divided by
then,
25
so that's
is
So we-
4. So that's 24.
Is it 24?
Yeah.
24, and what's 24 times 3?
A lot. That would be
48, 72. So 72 miles per hour is how fast they have to travel on that third leg to make up their overall average time. That's considerably faster compared to the 50 and the 60 that they were traveling. For most of us, we're probably thinking, oh, 72 miles per hour, that's no big deal. We go down the highway, we probably travel a little about that, hopefully a little less. But if you're traveling the rest of your trip at 50 and 60, so maybe the speed limit's only 55. And all of a sudden now you're going 72 in that, then you better watch out. You got to be careful. Okay? That's how you find the average rate of change, or overall average rate, sorry, and use it in 2 different ways. One, they're going to give you all the information, what is the average rate? And then the second situation, they're going to give you some numbers and say, oh, if there was another leg to this trip, how fast do they need to go to get that final average rate? Any questions? Your homework. Page 274. 2, 3, 12, 17, 21, 26.